In my previous tutorial, I showed you how to create a patrolling AI. This AI is capable of finding its way from one point to another regardless of the environment or any sort of obstacles that are thrown in its way. Doing this, the AI is capable of wandering around so it can eventually find you or anything else that it may want to find. In this video, I'm going to show you how to take that one step further and set up this AI so it's not only capable of patrolling that same environment, but so that way it's also capable of detecting and following you. Then once it's finally lost you, go and search for you before returning to its patrol path. But before we go ahead and jump into that, if you enjoyed this video and want to see even more just like this one, be sure to like and subscribe button down below. And with that, let's go ahead and jump right into the video. All right, so here's a quick look at our AI. As you will recall from the last tutorial, he's just kind of patrolling around. I drastically reduced his vision in this tutorial just in order to keep him from detecting me, and so that way I can easily get away from him. He'll still detect me, but he has to be significantly closer than you'd probably like. One quick thing that I want to note before we even get into the tutorial and I even show you anything is one very important thing about working with these AIs, I do not suggest you working with these AIs and trying to detect a player while using the default VR pawn. And let me show you real quick why. If I go and teleport over here, he should, there you go, he detected me. But you'll actually notice he did not come to me. He came this direction over here. And if I like move a little further away, you can, here, let me see if I can get a better view of this. Come on. There you go. You should hopefully be kind of getting a view that he's not coming to me. He's coming to another point, and the reason for this is actually because of how the VR pawn is set up. By default, the VR pawn actually has a point. For me, it's right around here, but it's wherever the center of your play space is. And so mine is somewhere right around over here. And so that's where he's actually going. He's not going to me. He's going to wherever that center point is, which can be a little bit annoying and is probably not what you're going for. If you're going to be doing something like this, I'd highly suggest using a VR character like I've done in this tutorial. I'll have it somewhere up in the corner. Or using something like the VR expansion plugins character, since that character is also set up pretty well for something like that as well. But anyways, you can this should kind of give you a general idea for how he's working. He did still come up to me, and if I go ahead and get away, he'll kind of sit over there. He'll kind of search around for me a little bit in that general area where I was last spotted. He kind of sits there for, I believe, if I recall, it's 5 seconds is the default. And then after a couple times, he'll return back to his patrol path. As you can see, he just did that because I interfered with him as he was going to that point. And that's the way it works for any of these setups. And I can, again, go ahead and jump into him. I can even jump in front of him while he's sitting at his post and then jump away. And again, he'll go on his little patrol path again, or his little search path before finally patrolling. And the search path is actually completely random. The way that works is it's a random point in the last general area where he saw me. So that's just kind of how that's working. And now he's back to his patrol path. So that should kind of give you a general idea. Let's go ahead and jump into this. I'll go ahead and show you how we set this up and how we can set this up so that way he's actually able to detect our player and he's able to search and then finally resume back to his patrol path. Before we can begin making any modifications to our AI, let's start by making just a quick modification to our VR pawn. We're going to give our VR pawn a tag called friendly. This tag is going to help our AI determine what it should actually follow. Because our AI is capable of detecting just about any possessable and even some non-possessable actors in the scene, we want to make sure that our AI will only follow what we want it to. So that's why we're giving it this friendly tag, so that way we're able to find our player itself and navigate to that area. A second quick note, you may want to move up your player start or VR pawn just 1 or 2 units in order for your AI to work correctly. Now, because of the way that our default VR pawn is actually set up, our AI is actually going to have a little bit of difficulty finding our VR pawn when it first spawns. This won't be as much of an issue when we're teleporting around, but on that first spawn, our AI will kind of go back and forth and just kind of struggle to pick up our AI if we're using the default VR template. So I highly suggest just moving up that player start 1 or 2 units, or your VR pawn just 1 or 2 units, in order to help our AI be able to find our VR pawn. Now let's get to working on our AI. We're going to start with the AI status enumerator that we set up in the previous tutorial. Open this up, and here we need to add 2 additional status options for our AI to have: detected and searching. Once you have these in place, you can go and close down this enumerator and move on to our behavior tree and Blackboard. I'm going to open this up the behavior tree so that way we're able to just quickly switch back and forth, but if you want to open them up separately, you certainly can do so. Let's go and start with the Blackboard. We're going to need a few additional keys for our behavior tree itself. The first one's going to be detected actor. This is going to be an object key, and this is going to be used for storing whatever detected object that we want our AI to follow. Make sure under base class in the details panel, you also set actor under the key type for this key as well. Then we need 2 vectors. The first one is going to be called last spotted location, and the second one is going to be called search location. These are both going to be used in order for looking around for our actor later on once we finally lost our VR pawn. Then the final key that we need to add into our Blackboard is going to be an int, and we're going to call this int search index. This is also going to be used for our detection when we're trying to relocate our player after he's been lost. Once you're done with that, let's go and return back to our behavior tree. And the first thing we need to do is we need to add a selector above the sequence that we set up in the previous tutorial. This selector will help us choose the behavior of our AI and allow for us to determine which path our AI should be taking and why. Let's start with our detected status. To do this, create a selector and place it all the way to the left of our patrolling status. And we're going to need to apply a decorator to this selector. This selector is going to check if status is equal to detected and set abort to both. Then below the selector, we need to set a move to and set the key to detected actor. Something else that I would also encourage is increasing the acceptable radius of this move to. By default, the AI is going to go straight to our player and kind of get straight up in the player's face, so we want to make sure that our AI will be spaced out a little bit away from our player. That's it for our detected. It's pretty simple here in the behavior tree itself, so now we can move on to the searching status. Again, we're going to need to add another sequence, and we're going to want to put this one right in between the patrolling and detected paths that we have already set up here. Then right below the sequence, we again want to add another move to, but this time our key is going to be set to search location, and then we want to follow that up with a wait. This wait is entirely optional. You don't have to use this if you don't want to, but I like this because it makes our AI look a little bit more like it's scanning around the area in search for the player. Now the current issue with this searching section is that we're not actually telling our AI where to go to actually search for our player. So let's go ahead and fix that. For this, we're going to need a new task like we had made in the previous tutorial, but this time I'm going to call this new task search area. Once you have this task opened up, we need to give it a few keys over here on the left-hand side. The first one's going to be called last location. Then we need a key called search location, search index, and AI status. Also, don't forget to set these Blackboard keys as public, so that way we're able to set them in the behavior tree later. Now, in the event graph, we're going to need to do quite a bit in order to determine both where the AI should be searching and how long our AI should be searching for. So let's go ahead and start by determining where our AI should be searching for first. To do this, get the event receive execute AI. Then get the last location, and we're going to get a random navigational point in a radius. This radius can be as large or small as you would like. I'm going to go and set this to 300 for this example. And then we can set this search location to our output vector. Because we don't want our AI to spend forever searching this same area, we also need to make sure our AI will stop and return to its patrolling path at some point. To do this, we're going to grab our search index as an integer, and increase this by 1. We're then going to pass this into a branch and see if this value is greater than some other value. Personally, I like using 4 as our limit. This is going to help us determine how many points our AI should find and stop at on its search path. So set this to whatever value you would like. Then after this branch, we're going to need to do different things depending on our true or false. So let's start with the false. If this is false, we're going to simply increase the search index and we're going to finish execute with success as true. However, if this is true, we're going to need to follow a few additional steps. First, we're going to need to set our AI status back to patrolling so our AI will return to that patrolling path. In order to do this, we're going to get a literal enum, so that way we can easily configure our enum input and we don't need to worry about our enum changing later on. Then we're going to need to set our search index back to 0 for the next time our AI has to start searching for a player. Then this next step is kind of up to you, but I want our AI to return back to the current patrol point that it was already navigating to. So in order to do this, I'm going to need to reduce our current point on our patrolling AI character that we have set up in the previous tutorial. In order to do this, we're going to need to get our patrolling AI by getting our controlled pawn. Then we need to reduce the current point by 1. If this value is less than 0, we want our current point to be equal to our patrol point's length minus 1. However, if this is false, then we want our current point to just be passed through as we normally would expect. Then once we've done either of these, we again want to finish execute with success equal to true, just like we did previously. Now, once we've done this, our task is now complete. So we can go ahead and return to our behavior tree, and we need to call the search area task that we just made. This task we want to call before our move to in the same path, and with that, our behavior tree is now complete. Now, don't close the behavior tree just yet. We are going to want the Blackboard open for references later on in this next step. So go ahead and leave that Blackboard open and return to our content browser. Open up the Patrol controller, and then first we need to add an AI perception component. If you would like, you can open up the viewport in order to add this in, but the AI perception does not have any visible transform, so it's not really necessary for our AI perception. Then in the details, add a sense config, hit the dropdown and set it to AI site config. This is what's going to allow for our AI to actually see our player. So here there's a few things that we are definitely going to need to do, and some of them you may decide you want to do completely differently than what I'm going to do here. First, I'm going to set detection by affiliation to all. Then I'm also going to reduce our AI vision for this test. You do not need to increase or decrease the AI's vision, but for testing purposes, I want to make sure that I can easily escape our AI. Then set the dominant config as AI sense site. Then finally, before we move on to our event graph, scroll down to the bottom of the details panel and we need to add onto target perception updated. Now we're ready to move on to the event graph. So here, we don't really need to worry about any other event. We're solely going to be working with the on-target perception update. First, we need to check if the actor has the friendly tag. Now, if the actor does in fact have this friendly tag, we need to store it for later. Next, we need to get some information from our stimulus. So go ahead and break that stimulus, and we need another branch to see if the stimulus is successfully sensed. Using this, we're going to be able to determine if our player is still in the AI site or if it's not. We'll start with if successfully sensed is true. If it's true, then that means our AI has either just seen our player or our player is in fact still within our AI site. So here we need to make sure our behavior tree has everything it needs to follow our player. So go ahead and get the Blackboard. Then we need to set value as object. For setting values on our Blackboard, we need to have two things. The first is the exact name of the key we want to set, which is why I suggested keeping the Blackboard open, as well as the value that we are setting the key as. So make a literal name and get the exact name of our detected actor. And then pass through our actor as the object key. Then we also need to set value as enum. This is going to be for our status. So again, go ahead and make another literal name, pass through the detected status, and pass through the detected status to our Blackboard. Now that is everything that we need for our detected setup. So now we need to move on to the searching, which is going to be just as simple. Back here on the branch, on false, we're going to need to set our values for searching an area. So in our Blackboard again, set value as vector, and this needs to be the last spotted location in our Blackboard. And then we're also going to pass through our stored actor's location. Then again, we need to set the detected actor, but this time I'm going to set it back to null, so that way we make sure that our detected actor can't accidentally be used later on. And we set the status enum, but this time we're setting it to searching. Finally, I'm going to go ahead and clear out the actor variable again, just to make sure that we can't accidentally use it later on. With that, our AI is now capable of not only patrolling an environment, but it's now also capable of both detecting the player and searching for the player once it's finally lost that player. I hope you enjoyed this video. If you did, be sure to hit the like and subscribe button down below. And also, I'll give a quick shout out to my Patreon supporters who you should see on screen now. And with that, I'll see you in the next reality.